Assalamualaikum and good day everyone. So in this video we are going to identify whether the given differential equation is separable equation, homogeneous equation, linear equation or exact equation. So let us start. So for the first one here, you are given the differential equation exponent x dy dx minus exponent xy over x is equals to x squared exponent ex. So when you take a look at this differential equation, this is quite similar to the general form of linear equation, which is dy dx plus pxy is equals to qx. Let us start by checking whether this differential equation can be written in the general form of linear equation. So how to get rid of this exponential function is by dividing all with exponent x, so that you will have dy dx minus exy over exx is equals to x squared negative x over ex. So if you simplify this one, you will have dy dx minus y over x is equals to x squared. So this exponent here, you can bring here, so you can simplify the exponential function to be over exponent 2x, or another way of doing it is exponent x here, you bring to the numerator part. Okay, so as you can see here, you can write the differential equation into the general form of linear equation. Okay, and it is satisfied the linear equation because the function on your right hand side is a function of x, the highest power of y is equals to 1. So therefore this is linear equation. Okay, let's proceed with B. Since the given differential equation in the form of y dy minus a function with respect to dx is equals to 0. So few of you might be thinking it must be an exact equation. Okay, so when you want to try whether it is an exact equation or not, first you need to write in the form of m dx plus n dy is equals to 0. This is your m and this is your n. Okay, and to test whether the differential equation is exact equation or not, you have to test del m over del y equals to del n over del x. So when you test for your m, you differentiate with respect to y, and for your n, you differentiate with respect to x. It is shown that del m over del y is not equals to del n over del x. Therefore, it is not an exact equation. Okay, some of you might be thinking maybe this is a linear equation. So how to test whether this is a linear equation or not? You have to try to rearrange the given differential equation into the general form of linear equation, which is dy over dx plus pxy is equals to qx. When you try to rearrange this differential equation, you cannot write into general form of linear equation. So therefore, this is not also a linear equation. So you end up with separable and also homogeneous equation. So if you want to test whether the given function is homogeneous or not, you have to write in the form of dy dx. Okay, so in this case, your dy dx is equals to x squared y squared plus 2y squared plus x squared plus 2 over y. So clearly this is not homogeneous equation. Okay, you have the homogeneity test, so you can test f lambda x lambda y must be equals to fxy, but for this case you will have not equal, so therefore this is not homogeneous equation. So you can try on your own this one and prove that this is not an homogeneous equation. So you left with separable equation. So how are you going to separate this function? So what you can do first is y dy is equals to x squared y squared plus 2y squared plus x squared plus 2 the whole thing with respect to dx. So take a look at the function on your right hand side here. So as you can see here, you have y squared and you have y squared. So you can factorize the y squared. Okay, so that you will have y dy is equals to y squared x squared plus 2 plus x squared plus 2 the whole thing with respect to dx. And again here you have two similar functions, which is x squared plus 2, and here you have x squared plus 2. So therefore you can factorize the x squared plus 2, so that you will have y dy is equals to, so x squared plus 2, so you left with y squared plus 1 with respect to dx. So clearly from here this is a separable equation because you can separate the variable x and y. So you will have y over y squared plus 1 dy is equals to x squared plus 2 with respect to dx. Therefore this is a separable equation. The next one here, C. So again you are given the differential equation in this form, so you might first think this might be an exact equation. Okay, so what you can do is write the general form of exact equation, which is m dx plus n dy is equals to 0. So by comparing this general form with what you have here, we know that this is your m and this is your n. Okay, so when we define your m, so m is equals to 3 cos x minus 4xy plus 2y. Okay, so differentiate this one with respect to y, so that you have to assume x as a constant. Okay, so that you will have negative 4x plus 2. So here your n is equals to, so expand this one first, so you will have negative 2x squared minus 4 exponent y plus 2x. And when we are going to differentiate with respect to x, so you know that y must be a constant. So therefore del n over del x is equals to negative 4x plus 2. So as you can see here, del m over del y is equals to del n over del x. So therefore this is an exact equation. So for D, maybe some of you might think this is a linear equation, but this is non-linear. Why? Because when you bring y to this side, so you have x dy dx minus y is equals to exponent y over x. If you get rid of this x, you still get non-linear. Dy dx minus y over x is equals to exponent negative y over x. This is non-linear because you cannot have a function of y on your right hand side. Is this the exact equation? So if you want to test whether this is an exact equation or not, you have to write in the form of m dx plus n dy equals to 0, and the next step is to test del m over del y must be equals to del n over del x. So in this case, if you test, you will have not equal. So this is also not an exact equation. You can try on your own and prove that this is not equal. Okay, so you end with separable and also homogeneous equation. As you can see here, you can write dy dx as a subject. Okay, so you will have dy dx is equals to y plus x exponent negative y over x over x. To show that this is homogeneous or not, we have to test for homogeneity test, which is f lambda x lambda y is equals to fxy. So by assuming dy dx is equals to fxy, so f lambda x lambda y is equals to lambda y plus lambda x exponent negative lambda y over lambda x over lambda x. So this one you can cancel out, and if we factorize the lambda at the numerator part, you will have lambda y plus x exponent negative y over x over lambda x. So this lambda can be cancelled out, so that this is equals to fxy. Therefore, this is homogeneous equation. So the next one, E. So clearly, this is not a linear equation. Although, as you can see here, you can write in the form of linear equation, but the highest power of y is 2. So this is non-linear. So what you can try is, we try to separate. Okay? Try to separate so that you will have 2 dy over exponent 2x dx is equals to x squared plus 1, the whole thing multiplied by y squared. Okay? So you can bring this one to the right hand side, so that you will have 2 dy is equals to x squared plus 1 y squared exponent 2x dx. So clearly this is a separable equation because you can separate the variable x and y. So that you will have 2 over y squared dy is equals to exponent 2x x squared plus 1 dx. So therefore this is a separable equation. Okay, the next one, F. So you have dy dx on your left hand side, and you have a function of x and also a y function over the x function. So as you can see, this one, it is quite similar to the general form of linear equation, which is dy over dx plus pxy is equals to qx. So let us try to rearrange this differential equation and write in the form of linear equation. So you will have dy over dx minus y over 1 plus x is equals to x squared exponent 2x. So clearly this is a linear equation. Okay, why this is a linear equation? Because you can write in the general form of linear equation, the highest power of y is 1, and you have a function of x on the right hand side. And the last one, T. Okay, So the given differential equation is in the form of m dx plus n dy equals to 0. So you can start with exact equation, okay, because the given differential equation is already in the general form of exact equation. So start with this one first. Test whether this is an exact equation or not. If it is not an exact equation, then we proceed with another 3 possible equation. Okay, so from here, clearly this is your m and this is your n. Okay, so your m is equals to 3x squared exponent y plus x squared. So differentiate this one with respect to y means that x is a constant. Okay, so differentiate this one with respect to y will give you 3x squared exponent y, because when you differentiate a constant you will get 0. So the next one, your n is equals to x cubed exponent y minus y squared. So your del n over del x is equals to, so in this case y is a constant, so differentiate this one will give you 3x squared exponent y. Since here y squared is a constant, so you will get 0. Okay, so as you can see, del m over del y is equals to del n over del x. So therefore this is an exact equation. That's all. I shall see you in my next video for more discussion. Bye. Assalamualaikum.